said I was going to. Okay. Okay, so first of all, we're going to talk about dividing this problem and then looking at the remainder. So remember when you're dividing, first of all, I want to point out one thing. This is the same thing as saying 426 over 13. Those are the exact same problems, and so you guys can see that division is actually, this symbol is just another way of writing a fraction bar, because remember, fractions are taking a whole and dividing it up into parts, and so this represents that a whole is divided up into 13, and we have 426 of them. So if I have 426 13ths, how many holes do you think we're going to have? If you guys were just to take a shot in the dark, how many holes I'm able to fill in every single circle do you think I'm going to have?
300.
300? Okay, anybody else?
How many whole numbers?
How many holes do you think I'm going to get? So I've got,
41.
the whole is divided up into 13 parts, and I have 426 of those parts. So how many holes do you think we are going to be able to get as I take those 426 and start filling it in?
41.
21?
41.
41.
37.
32.
390, don't use your calculator. Okay? I told, why are you cheating? You're not going to be able to do this on your test. Get out of that habit. Use your noggin, not your finger. Okay. All right, so basically what we want to do is, you guys, we all have a guess of what we can do, but we're going to set it up, and we got 426, and we're dividing that by 13. So I'm going to do the division the way that I told you guys. Okay, what can I multiply 13 by to get close to 42, or what can I multiply 10 by to get close to 40? It's probably not going to be the full out 4 because of that 3. So what we're going to do instead is we're going to start out and we're going to multiply it by 30. So what's 10 times 30? 300. So first I'm going to take away 300. So now I get 126. And now what's 3 times 30?
30. Oh, 90.
90. So now I'm going to subtract that. So now I get 36. Okay, so now again, I'm going to sit there and think, what can I multiply 13 by to get close to 36? Or what can I multiply 10 by to get close to 30 without going over? So I'm going to make this a 2. 10 times 2 is 20. Subtract that. And we get 16. And then what's 3 times 2?
6.
6. So we're going to subtract that. And we get a remainder of 10. So our answer here is that we have 32 holes. So we're able to fill in 32 whole circles, but then we have 10 left over, or 10/13ths of a circle left. All right, any questions on that?
No.
Okay, because now we're going to connect this. A mixed number looks just like what we found. So we had 32 and 10/16ths, or 13ths, sorry. That is in the form of A and B over C, where A is the whole number. What is B going to be? What was 10 in our problem from the last slide? Where did that 10 come from? The remainder. B is the remainder. And C is what we divided by, or what's called the divisor.
So it's like a visor you put over your head if it like divides into 2 pieces.
A visor divided?
Yeah.
Okay.
Oh, yeah.
A visor divided cannot stand.
Okay. We killed her, guys. We killed her.
Okay, on this one, the C is the same thing. This is the divisor. But D is what we were dividing. And that's what we call the dividend. Which is a lot cooler in Alaska because that's like $10,000 a year if you're an Alaskan citizen. I know.
We should all move to Alaska.
No.
Alaska's different.
During the summer, it's pretty awesome though.
Really?
Good.
Yeah. Especially if you don't need a whole lot of sleep because it's like daylight forever. But then
Daylight
if you're
forever.
outdoorsy, it's really awesome. We got this answer by dividing, right?
Yeah.
So if I'm going to go the other way, if you're not outdoorsy, yeah, stay to your cities because Alaska really doesn't have them. All right, so first of all, we're going to talk about how to convert a mixed number to an improper fraction. So if you guys remember from this slide and go from mixed number to improper, what should I do if I'm going the other direction?
Multiply.
Multiply, yeah. So the first strategy to convert numbers into improper fractions, you multiply the denominator by the whole number. So in this case, what's my denominator and what's my whole number?
4 times 8.
So we're going to do 4 times 8. And then it says add the numerator or add the remainder. So what am I adding to this?
7.
7. And then this becomes my new numerator. And so we're just going to simplify 4 times 8 plus 7. So 4 times 8 is
30.
32 plus 7, which is going to give us,
39 over 8.
and so that's what this fraction is as an improper fraction. Okay, now what do you notice that about this fraction? This is an improper fraction. The one we started out with was an improper fraction. What makes them improper besides their manners or something like that?
Because the bigger number is on top.
Yeah,
rather than
the
on bottom.
improper fraction is when the numerator is greater than the denominator. So you know you have an improper fraction if this is true. All right, so let's convert 7 and 3/5. What do I do first?
5 times 7.
Okay, so 5 times 7, which is going to give me 35, right? And what am I going to do to that?
Add 3 to it.
Add the 3. So now this fraction becomes
38 over 5.
38 over 5, and that's what it is equal to as an improper fraction. Questions? All right, so this is the strategy I learned in converting when I was a kid, and that I've done pretty much my entire life. This is the one that your book likes to do. Okay, so first of all, when we have a mixed number, it is actually the sum of the whole number and the fraction. So 5 2/3 is actually equal to 5 plus 2/3. All right, so now I have two fractions that I'm adding. 5 is, remember, as a fraction is written as 5 over 1. What do I have to do to add these fractions?
Have a common denominator.
You have to have a common denominator. So out of 1 and 3, what do you guys think the common denominator is going to be?
3.
3. So I don't need to change the 2/3, but what do I have to multiply the 5 over 1 by?
3.
Just 3? 3 over 3, which is going to give me
15 over 3.
15/3 plus 2/3, which gives us the answer of, and that's where that came from. All right, what do I rewrite about 6 4/5 if I'm going to use this strategy? What does it become? 6 plus 4/5, which is equal to 6 over 1 plus 4 over 5. Okay, what's my common denominator? 5. So 4/5 is going to stay. What do I have to do to the 6?
And then by 5.
Just 5? 5 over 5, yeah. So 35 plus 4/5 is going to equal.
34 over 5.
Okay. as you guys probably noticed, the strategy method 1 was more efficient. It seemed like less steps. However, one thing I do like about this strategy is it keeps you reviewing about what you have to do to add denominators, and it also makes clear that mixed numbers are actually the addition of those two values of the whole number and the proper fraction. Your choice. You have to convert these into improper fractions. Now, one thing that I do want to point out is, let's do number 5 together really quick. What kind of fraction should this be at the end when I convert it to improper?
Negative.
It's negative, all right? So you know it's going to be negative, and then you're just going to go ahead and convert this as it is, okay? So if we do it in method 1, what do I do to convert this? 4 times 8, which is 32, and then what do I have to do with the remainder? Add 3, so that's going to become what? 35, so this is negative 35 over 8. You treat it just like a positive one, but you make it negative at the end. All right.
Even if it's positive.
What do you mean, even if what's?
Oh, never. I thought you said like, even if it's positive.
So you convert this into, so you treat just the fraction and you convert just the mixed number and the fraction to improper, and then because of the negative, you make it negative. Okay? All right, go ahead. See if you guys can do the other 7. Yes.
So this is negative.
Yes.
So if I understand this correctly, it's say 4 times 8.
Mm-hmm.
And then you take the remainder of what's left and you add it.
You take the numerator as the remainder and you add that, yeah.
You add it to that, and then that's that. And then you just take 8.
Yeah, the denominator stays the same.
And that's true for all of these?
For all of these, it should be true, yes. All right, once you get them done, compare your answers to the ones in the red. Make sure you did it right. If you have questions, please make sure you ask. Make sure you're able to do it. Not that you're able to copy it down. I'm pretty sure everybody's really good at copying down. We kind of excelled at that up to the point where we graduate from high school, just copying things now. History class for me was a lot of times just regurgitating what my teacher wanted me to
Regurgitate.
like, the verbal regurgitation.
Yeah.
Like memorize everything. Otherwise you fail.
That was always why I didn't like history, because I felt like I just memorized everything, and then as soon as I walked out of my test, I just forgot about it. I appreciate it more now when I see applications of it in the actual, like, that whole thing of we learn history because we don't want to repeat it. Yeah, I see that as a big deal nowadays.
Because everyone's repeating everything. Like all mistakes.
And they actually really appreciate what I did learn about, like, Stalin and the beginning of socialism and then its conversion to communism. I really appreciated that.
Oh, yeah.
It's
Yeah.
heavy stuff when you learn about how they start stuff and Stalin, you know, but
Now we are going to work on going the other direction. So to be able to do this, we have to actually divide. One of the things that it becomes kind of useful if you can do it is to look at these problems because we've been looking at simplifying fractions, to look at them and be able to reduce or factor them first to be able to get things that they'll go that we can divide out, having the same numbers on both the top and the bottom. For example, 285 and 24, not both even, so we can't divide by 2. However, what is 2 plus 8 plus 5?
15.
15. Is 15 divisible by 3?
Yes.
Is 24 divisible by 3?
Yes.
So we can actually reduce this by 3. We can divide both of these by 3. So if we go 285 and we factor out a 3, what do you guys think is going to be left? How many times does 3 go into 28? What's the closest we can get?
8.
9 times, yep. And what is 3 times 9?
27.
27, so we've got 1 left. So how many times does 3 go into 15?
95.
5 times, so 95. So we can rewrite this as 3 times 95, and then 3 times what for 24?
8.
So we can divide those out, and then we can actually divide 95 by 8 instead. So we know that this can be at least 10 times, so we can subtract 80 from that. That gives us 15. How many times does 8 go into 15?
1.
Once, so we can subtract 8. And there's our 7. All right, so this tells us that we have 11 holes. And what's our remainder? 7, so that's our numerator over 8. And then that would be our division problem. Reduced. So that's the other nice thing about this, is that our fraction is automatically reduced. All right, both of these are even, which means we can divide both of them by 2, right? Okay, so this is 2 and what's 34 divided by 2?
8, 20, 18.
How many times does 2 go into 3?
1.
Once with a remainder of 1, right? Because 3 minus 2. How many times does 2 go into 14?
7.
7. So this is going to be 2 times 17. All right, we got to do 1432. I feel like I'm talking about a year. Should have done 1492, and then we could be like, the Columbus sailed the ocean blue. Okay. All right, how many times does 2 go into 14?
7.
7. No remainder, right?
Yep.
Okay, how many times does 2 go into 3?
1.
Once with a remainder of 1. How many times does 2 go into 12? 6. All right, so we have 716, 2 times that. All right. Yes.
Sorry, I didn't catch it on the last one or this one. How are you factoring that out in like a huge number?
Okay. So I'm doing division,
Okay.
which means when I'm doing 285 and I'm dividing by 3, so we're going to connect this to here. I said 3 goes into 28, 9 or 90 times. So we subtract the 270. You're left with 15. This one is the one that I put right there to make the 5 a 15 instead.
Okay. Why'd you choose 3, or did you just choose it?
Because both of these numbers are divisible by 3 by the rules of divisibility. They add up to numbers that are divisible by 3.
Okay. Awesome.
Okay? So you're okay with that?
Yes, I don't remember all the rules, but I know what you're talking about.
You can get the worksheet out if you want,
Yeah,
which is pretty useful, to be perfectly honest, until you have them all memorized. Okay? These two are both divisible by 2 because they're both even. So what I did on this one is when I do 34 divided by 2, I know it's going to go in 10 times, so subtract that. And then I have 14. This one is the one that I put right there.
Yep.
To make it 14.
Where'd 34 come from?
Right here. Yeah, the actual number, factoring it, I was just showing doing this is what I'm doing right here.
Oh,
I'm just not writing it out as a division problem.
okay. And
Then on this one, again, I am dividing 1432 by 2, 7, that was 1400, subtract that, gives me 32 left over. 2 goes into 30, 10 times, subtract that, that gives me 12. This one is the one that I put right here.
Okay.
And then I just went, how many times does 2 go into 12? 6, and then like that.
But
Okay.
you don't actually need that one up there. It's just showing you that it's 12.
Say that again?
You don't actually need the one up there, it's just showing you that you have 12.
Yeah. This one is basically after I've gotten rid of the 1, 4, and 3, I still have a 10 left over to make that 12. And so I need to consider that. Okay? Okay. So now we've got 2 over 2. What happens there?
Cross that out and then divide 7/16 by 17.
So now, and what's going to be nice about this is our fraction's going to be reduced. Okay, so how many times, remember when it comes to these kind of problems, a lot of times it helps if you round, so round up to 20. How many times does 2 go into 7? 3. So we're going to try doing 3 right here first. Sorry, not right there on the 10 spot. So, what is 3 times 10?
30.
Well, like 3 times 10.
30.
So we're going to subtract that. Sorry, 30 times 10 technically, but so we got 416. And then we're going to do 3 times 7 or 30 times 7, which is,
I thought you said you were going to do 20.
I know, we treated it like 20 to figure out what we should multiply by.
But now you're doing 10.
I
Oh,
did
okay.
10 out of the 17, and now I'm going to do
I
times
see.
7. Okay, so 3 times 7 is 21. Put a 0 there, subtract that. We have 206. Okay, I think I can go and do another 10 there. So add 1 to that, because if I multiply by 10, this is going to be 170. Subtract that, we get 36. All right, and then how many times does 17 go into 36?
1.
Okay, let's go with once. Subtract 17. That is going to give us 19.
Yeah.
Yeah.
All right. My remainder is bigger than my divisor, so I should do it one more time. So I'm going to add a 1 here. And what's 19 minus 17? 2. So that's my remainder. So what we have is this is 4. So we've got 4, and then this is 2, so 42, and a remainder of 2 over 17. Yeah, so we're not as big of fans of converting into mixed numbers, right? Because it's actually division. Yeah, nobody ever is. Well, okay, maybe some people. Sure. Okay. Division sucks, right?
Yeah.
I like dividing when I do it my own way and kind of have fun of like seeing how many different strategies I can use. But for the most part, long division sucks. So let's talk about. All right,
Hold on.
now
Would you be able to go back for just a second?
let's talk about these problems. So first thing we're gonna do is we're going to look to see if we can reduce any of these. Okay, so that's gonna be what we're gonna do for this before we actually do any of our division. So out of 125 and 14, do they have a number that goes into both of them?
No.
No, they're not both divisible by 2, they're not both divisible by 3, they're not both divisible by, they're not divisible by 2, they're not going to be divisible by 4, 5's out, 6 is out, 9 is out, so this one we can't reduce. Okay, what about 2?
Yes.
Okay, what can they reduce by?
3.
Everybody okay with that?
Yeah.
Okay, remember we add those digits up. So what's 5 plus 4 plus 3?
9 plus 3 is 12.
12 and 8 plus 1?
9.
And both of those are divisible by 3. So we're going to reduce both of these by 3. So we do 554. Okay, how many times does 3 go into 5? So we're looking for, at this first number, 3 goes into 5 one time with a remainder of, so subtract those,
2.
2. So we cross out the 5 and we bring the 2 over to 24. I'm going to write this bigger. So here we are, 543, and we're factoring it by 3. So 3 goes into 5 one whole time with a remainder when we subtract those of 2. So now it becomes 3, and how many times does 3 go into 24?
8.
8 times. Is there going to be a remainder?
No.
No. So we're going to cross both of those out, and now we're just going to figure out how many times does 3 go into 3? Once. Okay, so this is going to be 181. All right, now we got to figure out how many times 3 goes into 81. All right, how many times does 3 go into 8?
Twice.
2 times with a remainder of 2. So now this becomes a 21. All right, how many times does 3 go into 21? 7. So now this is 181 over 27. All right, is there a number that's going to go into both 141 and 8?
You mean 181?
141. We're moving on to the next one.
Oh, I see. My bad. Sorry.
No.
Nope, so we can't reduce that one. Okay, is there a number that goes into both 520 and 25?
Yep. 5.
Okay, both of these are, we can reduce by 5. So we're going to do 520. Okay, how many times does 5 go into 5? Once. How many times, is there a remainder?
No.
No, okay, so we took care of the 5. How many times does 5 go into 2?
It doesn't.
It doesn't, so what number would that be?
0.
0, and then we still have the 2, but now it's with the 0. So how many times does 5 go into 20?
4 times.
4. So this is going to become 104. Okay, how many times does 5 go into 25? And we've reduced that one. Does it stay negative after we reduce?
Yes.
So yes, still negative. All right, what's the number that goes into 7,280 and 235? 5 is going to go into both of those. So 7,280. Okay, how many times does 5 go into 7?
1.
Once. Then what do I do with the 7?
Reduce it down to 2.
Cross it out, and I have a remainder of 2. Okay, somebody tell me what I should do next.
Trying to see how many times 5 goes into 22.
5 goes into 22, which would be what? 4 with remainder of 2. So I'm going to cross these out and put a 2 by the 8. Okay, what do I do next?
28 goes into
How many times 5 goes into 28? How many would that be?
5.
5 with remainder of 3. So I'm going to cross the 28 out, and I'm going to put a 3 by the 0. And then 5 goes into 36 times. Okay, so this is going to be 1456. All right, so 235. How many times does 5 go into what?
28. Or 20. Or 200. Sorry. No, it's not.
So it's not 2, so it doesn't go into 2, but we don't want to start the number out with a 0, so we're going to move over to 23. How many times does 5 go into 23? 4 with a remainder of 3. So we're going to cross out the 23, and we're going to put the 3 by the 5 there, the remainder by the 5. And then 5 goes into 35 7 times. So this becomes 47 on the bottom. What?
Did you learn this already?
No.
Of reducing fractions?
Yeah.
We learned how to factor
Kinda.
already.
Because this is like so clever. Oh no.
Of dividing them out?
Yeah.
I don't think I mean, I personally divide like this when I'm setting it up, but I don't know if I've taken step by step with everybody, so. All right, 23 is a prime number, so do you think we have any hope with that one? Unless 23 goes into 789 evenly, so no, we're not gonna worry about that one. What about 84 and 5?
No.
All right, and then we have 23 again, so none of the rest of these reduce. Okay, now I am going, before we actually do this, I'm going to give you guys a fraction, and I want you to reduce it just like we were talking about. I want to check to make sure we're all capable of doing this. Being able to divide with a common factor that you know. So we're going to do... Okay, I want you to reduce this fraction. So I want you first, A, identify what's a number that goes into both of them, and B, be able to reduce both of them. This is your chance to ask individual questions.
Five
Mhm.
goes into there's a remainder of five. Or no, there's a remainder of like 5 times.
Okay, 5 goes into what again? Sorry. Okay, how many times are you saying that? Okay, so you put down a 4 first. Nope, nope, keep your 5, but your next branch is gonna have a 4.
What else did you add?
Okay, with the remainder of what?
I just said something.
Okay.
Sorry?
It's like 4.
Okay, so you're gonna cross out your 24, and then you're gonna put 4 by the 6.
46, so now it's 46.
So now you're thinking, how many times does 5 go to 46?
Are you done?
Oh, you're good. I was just
And
wondering.
I just by moving the remainder out.
Mhm.
This right? Better if 5 more 24 minutes.
Yep.
Sweet.
Does that look right to you?
Yep.
Okay, perfect.
Yep.
Remainder would be
How are you
45, right? With the denominator?
Denominator should be 5. I got 5. That's, yeah, I wanted to do 3 over 5.
If you don't participate,
Yeah, we're good.
Well, 19 isn't the full.
I realize that you.
Let's go do.
Man.
What part do you want to fall?
I don't really have a position yet.
Okay. We're trying to get into.
What did you
I'm
get when you
trying to play
reduced
offense,
it?
Gotcha.
but they want me to play defense.
Okay, this is what I
I
said
feel
for
like
you.
that, but
Yeah.
I'm just
You converted
Get
it
on the
already,
team.
that's awesome.
happy to play.
Yeah.
I was right here.
Yeah, that's my
So I just,
I'm on the picture.
So yeah, 5 goes into 24 how many times?
Yeah, choose fire.
Do you have like an idea of like which high school? Is it high school?
4, because 5
I
times
want
4
to
is
choose
20.
high school fire and then eventually graduate.
So you put down a 4 on your second branch.
Actually, one of
It'd be
Yeah.
fun to go back to my old high school.
Okay, now what's 5 times 4?
Oh, really?
20, so what's 24 minus
I
20?
went from Twilla.
Is that required?
4, so you're gonna cross out the 24, and then you're gonna put a 4 by the 6.
I did.
Oh,
I did.
So you always cross out the numbers you just used, and then you put your remainder by the next number.
Twilla High School.
So now that's 46, so how many times does 5 go into 46? 46?
Oh, 46.
Yeah,
Yeah.
9, so you put a 9 down.
What's
Okay,
up, man?
what's 5 times 7? 45 plus 46 minus 45.
Just feel like
1. So you're gonna cross out the 4 and the 6,
I have like 20.
and then you're gonna put a 1 by the 5. You minus when you
You
multiply
know we
these
get
from the number
they
you're
make
looking
us in the
at.
summertime get a nice bed.
No, right?
And I don't know how I feel about that.
Then you put the 1 by the 5, and then you do it again.
Like,
Okay.
it's my feet going. I'm just like, oh my gosh, I can't do this.
So, last thing I'm going to show you guys is, yes, this is the kind of thing of being able to identify numbers that go into both the numerator and the denominator, and being able to do this by hand is something I want you to show me. But let's be perfect. How we can use our calculators to be able to do this, and a basic calculator, not calculators that work in fractions. So we're talking about a calculator that just does our 4 basic operations: multiply, add, subtract, and divide, okay? So what you want to do when you just have a basic calculator is you're going to take this right here and you're going to put it into your calculator just like it says. So 181 divided by 27. All right, so I am giving you guys permission to get out your calculators and put that in there and tell me what the whole number is.
0.70377.
I just want the whole number.
6.
Okay, 6. All right, so that is the whole number. That is the A value for our mixed number. So remember, a mixed number is A and then B over C. So we know that A is equal to 6. We also know that 27 is equal to C. We just need to find our remainder. How do you guys think we can find the remainder?
By timesing 6 by 27.
Yeah, B is equal to 27 times 6, and then we're going to subtract that from 181.
162.
So it's 181 minus 6 times 27. So 181 minus 162, which is equal to 19, right?
Over 27.
So our answer is, we've got, here's our A, here's our C, here's our B. So this one, I am totally running out of space because I'm writing too big, is equal to 6 and 19/27. All right, using your calculator, I want you guys to show me how to find A and how to find B. I want you to use your calculator and do this one, 125 over 14. Remember, where does the A come from and where does the B come from? I know all of you have phones, so I know you all have a basic calculator. This is so crazy. I just tell people, get your calculator out, and then there's people that are just sitting there. First time all semester I've said, hey, you have permission to use your calculator.
Is it one, in your example, is it 181 minus 6 times 27?
Yep. In doubt, I'll just use my phone. All right, so again, calculator, basic calculator, just does the normal operations. First thing I want to do is I want to find my A value by actually dividing these two. So 125 divided by 14, and just looking at the whole number. So what's the whole number in this? 8. So that's my A value. Okay, then I want to find my B value, which means I'm going to take the original numerator and I'm going to subtract from that my whole number times the divisor. So if you think about this, this is D minus A times C. So now I'm going to do 125 minus 8 times 14. I get 13. All right, so what is this as a mixed number?
So that'd be like,
I'm going to have 13 over 14, yeah, because remainder over divisor. And then the whole number out front. Because remember, these look like A and then B over C. All right, let's convert, last one, 141 over 8. Convert that to a mixed number.
You're just viewing that.
Okay, what did you guys get?
17. 5 over 8.
5 over 8.
Okay, now I want you guys to let's make a connection here really quick. If I want to convert this into an improper fraction, what do I do again?
Multiply
14
8 by
times 8.
14. And then
8
add
times 14. Look, 8 times 14. Then what do I do with their 13?
Add it.
Add it.
Add it. If I bring this over to the other side, wouldn't that be what I just had? Is that 125? Add this like I'm solving is equal to 8 times 14 plus 13?
Yeah.
Yeah? So really, this comes directly from doing the opposite of converting from mixed number to improper fraction. Okay? So we are doing the opposite. Instead of adding, we're subtracting. And remember, to get the 8, what did we have to do to get the 8? Instead of multiplying, we divide it, right? So this is the result of dividing. Okay. This is basically what your homework is going to be on, is converting. Okay? I do expect you guys to limit your calculator time. You can use your calculator to do this right here for the actual division. But I'd like you to make sure that when you're reducing your fractions, you use your rules of divisibility, and also that you convert mixed to improper by hand. Okay? Do not become so reliant on your calculator all the time.
We got a quiz.
Your brain is the greatest one. We're going to do the quiz tomorrow.
Okay, cool.
Okay, did everybody hear that?
Quiz.
Quiz tomorrow. Even though there's a quiz that's on Canvas that was actually due last night, that's actually going to be tomorrow. I just haven't had the chance to fix it yet.
Okay. Do we have homework tonight?
You do have homework tonight. Yep. It's on Canvas. It's in the book.
Okay.